Hey everybody, so in this tutorial we'll learn about how to build and deploy .NET Core applications using Docker in Docker Hub for container registry, and automated the whole process using GitHub Actions for the automation. So we could hook this process to, say, when you push to the master branch, it's going to deploy to your Linux server. So what I have here is the basic .NET Core applications that's running on macOS, but I'm running on Linux containers. So I'll just switch over to Sublime. And yeah, so I've got, it's an MVC setup, so it's got a home page with an index action, and then it's got this members that's reading members from the database. So we'll get to that in a moment. So for the models, I've got a database that basically connects and runs queries for us. The users are basic users that we have here. This save isn't really used. It just stays there. For users, again, it's just listing the users that we have from the database in some utility model. And I have the views here. I've got the home pages static, like dynamic static UI built with Tailwind CSS, and the members is basically iterating through those members that we have in the table and just displays them there. So, and the root folder, we don't have much other than a fav icon, like default icon for the browser. So what I have here is a .env. So this is our environment variables where the environment variables would live, the environment type, and then the HTTP host scheme. For the MySQL, the credentials for the system administrator user. So that's what we pass for SQL Server. So yeah, for containers, it uses two containers here. One for the web, which is .NET Core, and then another for SQL Server. We'll start with this .NET Core here. So the build context is right in this root folder. So it pulls from this public image from Microsoft. It uses 3.0, the version of that SDK, copies the files that we have, like everything here, and it just restores and builds. And then the entry point maps to this file here. It is a, it just checks the environment, checks the environment. If it's dev or development, then it would run watch, so you would, it would reload whenever you do, it's called hot reloading, except that it's a little bit slow depending on your machine. Testing as well, you could run unit tests if you configure them, and then some catch-all, which basically runs by default. It would run the standard run for us. So next we've got the SQL Server here, which is built in this context of this folder here. So the container, the image used is from MSSQL, this public image registry, and it basically runs a few things, including an initialization script. So it pretty much automates the setup of these tables for us. So whenever this is run initially, it would install the database. I mean, not initially; it runs it all the time. So make sure you don't do duplicates and check. Like for example, here you see if it exists, like just to avoid those certain errors. So yeah, it creates a database, that table of users, inserts some sample data, and you could basically like add a few more migration scripts here if you want, or even have duplicates of these and pass the migration names and do the error checking as needed. It's up to you. So yeah, once that is done, then it would run pretty much what we have there. So push that YML. That wasn't supposed to be there. Okay, so with that out of the way, I've got the startup here where I configure the routes. It's pretty much, it uses 2 or 3 routes, 14404. I couldn't figure that one out. So I had it to map to its own random route in there, which is defined on runtime. All right, so the root folder is / it just maps to this controller that I've mentioned here, to the index action. It shows that Tailwind CSS UI, and then / members would show us the table of those members. So talking of prerequisites, you would need Docker running on your machine. So if you're on if you're on Macintosh or Linux, you can actually use Docker Desktop. So yeah, the application, it's like a fancy application that would run here. Otherwise, you could always like just install Docker Engine. Well, it's also available for Linux, so that's pretty good. So you can either have Docker Desktop or Docker Engine, and you start it like make sure that Docker service is running, and you would need Docker Compose. So if Docker Compose doesn't come with the setup that you have, then make sure you install it separately, because that's needed in this tutorial. So yeah, after you do that, you would need to log in. With the desktop application, you can just click here, and it would say login. It would prompt you to log in there. You can also just log in from the CLI to Docker login. It will ask for username and then a password, or it would take you to an authorization like URL. But for me, I already logged in, so it checked the credentials that I already have, and it just went through. So yeah. Next is I'm just going to go to GitHub and then .com/a. I'll just create a repository for this setup. But first, let's just run it first. So you do docker compose up -d. So it's going to be running. I've already like have built these images. So if it gives you an error, then make sure you do docker build first. Otherwise, I'm pretty sure like running this initially would prompt the Docker to build those beforehand, and then it would run them. But if that doesn't happen, then make sure you do docker compose build. So if we do docker ps, we see that we have two containers running, and this one maps to that localhost. So if I open that in the terminal in the browser, it's going to give me this sample basic UI, which got these members here. So this is where it does the database query, and it pulls these from the database. So pretty basic stuff. I just wanted to cover at least two containers, and I couldn't think of another service to use other than a database. I mean, that's a good thing to cover. I guess it's widely used. All right. So next, I would just want to create a repository for this. I would call it .NET City. .NET City. I think I already have one. Oh, I'll just create another one. So .NET City 2, and I'll just set it to private for now. And you go back to your folder and do docker get init, initialize it in an empty repository, and then just map that origin and git add everything initial, and then git push. You have to set the upstream. Okay, so we've got that pushed to the central repository there. Next is we want to create a workflow action. So we could just Google GitHub. We'll see some more sample workflow actions. Something dimmer for us. I mean, we wouldn't have to type everything from scratch. So GitHub. Let's try this repository here. Okay. You've got this CI here. We'll just copy. We'll just borrow their code. So what you want to do is create a .github encoder .github folder, and in that folder you want another folder called workflows. Yeah, so it says .github workflows, and then so it's multiple directories to be created, and then we're going to have that folder created here. We're just going to create a new YML file. We'll call it CI or push.yml. You can name it whatever. And you could just say docker CI, or it's CD, by the way. We're doing continuous deployment. So yeah, it listens to whatever push you do to the master branch. After that, let you set up the master branch, and then yeah, you're gonna have a few jobs. One for deploy. We're gonna have one for deploy, and then one for build, and then one for deploy. So build and then deploy. So what basically build is going to do is it would just build it would use the SSH. I mean, it would use the action agent to build the image and then push it to the container registry, which is Docker Hub. So it would update our image there, and then deploy would basically SSH to connect to your server and then pull those images that were just pushed and refresh your application in case it was already running. So for this one, I could just say runs. We'll borrow pretty much all of this code can be borrowed. So it runs on Ubuntu latest. Check out v2. Yeah, we don't need these options. We could say first thing that we want to do is login. So login, and then since we're doing login here, we need to pass credentials. So in environment, we could say user is. Yeah, we're going to set up we're going to save these via GitHub Actions. I mean secrets. So we could say secrets that user or Docker user, username, and then password. And that is going to be, yeah, so these would be populated to the environment variables on the SSH agent. I'm sorry, on the action agent. So when it comes to the action itself, it's going, I mean the top command, it's going to be docker login. We pass these in line, so it's going to be user. It's username, so user, and password is pass. So yeah, whatever you name here, you make sure you pass it as the variable. So that does the login for us. So we suppose like this action is successful, it's going to proceed to the next step. Sorry, it's a step, not an action. Action is pretty much everything. So next is we want to make sure we want to initialize the environment. So because our Docker Compose here relies on the .env file, and because we don't have it tracked in the source control, it would throw an error if it wasn't there. So we could just make sure we set up the environment. Like we duplicate it basically from .env.sample. So name setup, and then runs. We just check if it's not there. I mean, obviously it's not there, but just doing this to be sure. Just -f. Yeah, so if the file does not exist, then we just copy it from this .env.sample. Right now, these environments that don't even matter, so you can just do touch that environment. So it's an empty file because we don't use those in the build process. We don't use any environment variables at that time. They're only intended for runtime. So in setup, and then another action would be, yeah, so we performed the login and we created that env file. Next, we just want to build the Docker containers and then push them as push them as the last step. So name, we'll say Docker build images, and then since we're using Docker Compose, we could just say Docker Compose build, and we don't need to use any caches in case some caches happen to be there for the sources like this one here, or the one for the database, the other one here. So build within skip cache. So in the next we want, I mean, the last step would be push into the to hub images, your public images there. By the way, like Docker Hub in their free package, they only give you one public image. I mean, one private image. You wouldn't have more than one private image unless you're a paid user. So we're going to keep this to have these images public. So you have you can have unlimited number of public images. So Docker push, and it's going to, so basically these are our names, these aren't commands. The commands are the ones we specify in the run in the run property. So Docker compose push. And for the deploy we want it to depend on the build. So we want to make sure the build is actually passed before we can do the deploy one. So yeah, for build it's going to So we can say needs, the syntax is needs, and the name of the step that we have there, I mean job. So it's spelled and then it runs on pretty much the same. And for the steps, basically it would let's just skip this for now, and then we'll test the build one. For the deploy, we're going to use an SSH agent for the action, so we would need to create a server actually. So just to review everything, we need to log into Docker there and build images locally, and then push those images that we built to the remote ones. So yeah, since we're pushing to remotes, I want to make sure the image here starts with the Docker Hub, like Docker Hub username, your username, and then the repository name, and then the version that you're pushing to. I'm just making it push to the latest for everything, for the sake of simplicity. So these actually have to be repositories that have been created. So you need to go to Docker Hub, and create those repositories. So we'll just do that right now. So create repository and name the repository that, and then create. Do the same for the database one. Then yeah, we created 2 repositories right now, and I guess we're good to go. We could just push this to the commit and push this to the GitHub, so it would create those steps for us. Like it would run those actions. So git status. Commit minus m. We could say and as soon as that happens, then GitHub would have a job running for us. So it shows right here, Docker CD. So this is the name that you have for the workflow action, and slash the job that's being running right now. So if we go to actions and go here, we'll see that it's currently running. So we'll just keep that. Actually, I just forgot we didn't set up the secrets, so we'll have to rerun this one. You have to go to settings and then secrets for the actions, and then whatever secrets we passed here, we have to make sure we do, like we define them. So for me, it's this one. For the password, I'm going to have to check my password manager. So I just set up these secrets. I had to go through my password manager to find that password, and yeah, since it doesn't know those secrets yet, I have to actually rerun this job exit code. Yeah, so we can just say, or basically pass those as empty username and password. That's why I didn't say any other error. Yeah, and right now it should be running another instance. Right, so the .NET Core container is already pushed. Next step is we want to spin up a server, like a Linux server. I'm not sure which VPS service, like cloud provider you're using, but for me it's just Linode. So I'll go to cloud.linode. Yeah, so Linode basically gives you free, cheaper VPS, like virtual machines. And if you want, you can just sign up using my referral link. I'll provide it down below. It's going to give you, I guess, like $100 credit, something to use in the first 60 days or something. Yeah, so be sure to check it out if you don't have a VPS provider already. So we want to just use a Ubuntu image. Oops, just use some deprecated one. So Ubuntu 2004 LTS. I guess New York is the closest region to me. It doesn't matter because I'm going to destroy this instance after this tutorial. So I'll just use shared CPU and the smallest one. I think the SQL Server actually requires at least minimum of 1 GB of memory. So I don't think you can run it on a single gigabyte of RAM. So yeah, just play with it and see if that works for you. Ubuntu, and then Ssh Key. Just cat. So I'm going to add my SSH key to this one, so I wouldn't have to log in using a password. And yeah, just verifying that everything. Yeah, it needs a root password, so just put something there that's random. No backups, no private IP. Everything seems to be perfect. We'll just continue and create the instance. So that took a while to boot this Ubuntu server, but it's running right now, so I can just SSH to this server. So SSH install root, then pass that. It's the IP. I already added my SSH key, so it should log in without a password. Yeah, so we just want to install Docker Engine and docker-compose on the server. So GitHub Action Agent would be deploying the code that we have there, like pulling from the containers from our public images, and then yeah, just starting the services. So they would need ideally, like not ideally, they would forcibly need that Docker installed. So this is a new server, so we'd want to update the package index. So update. You want to go to Docker instructions for installing Docker Engine. So we're installing this for Ubuntu right now. Just follow their steps. So install all the versions. We don't have those installed. Update is already done. Okay, so those components are there. Can then run the next one. And then we update. Since we have the new repository there, we can just do update and then install Docker from the source. Their own repositories there. Okay, so that took a little while. Now we have Docker installed and Docker is running. So if we do service status all, you can see that Docker is running there. All right, so if you run their hello world, it should echo that message to you. Okay, so everything is working. As I said, we want to use another user that's not root. So we have to actually follow the steps for like adding that user to the Docker group to allow them to run the containers, like manage containers. But first we want to install docker-compose. So it's not there. Install. So for Linux, and then just move it to the executables, binaries, and then Yeah, so it's working. You have docker-compose installed. Google docker post installation. We want to create our user, which is going to be saved in GitHub secrets, which would be running our action, like the deployment via SSH. So it would be this one here. I don't have this user created yet. Just save this reference for these secrets, and it's going to, so we'll just use add user, and then it's .NET, and then the password is going to be what I just copied. Confirm the password. These don't matter, and if you change to that user, docker, what is it? Yeah, .NET, right? So this is our user right now. If I say docker run hello world, which is right here, it would give me that error. So you see it says permissions denied, so we have to follow this post installation script. Add user group, add group add docker. It's already added when you install Docker. You would just need to execute this command as root. So I exited that .NET session, and I'm back as a root, and I would basically this command would add .NET user to that group. So whatever user you specify, make sure you place that here as well. For me, it's .NET, and you press enter, and then now you can switch back to .NET like that user. And if we run again that hello world, I think it should be running right now. Yeah, so everything's running there. Next, we want to make sure that this user here can actually read from the repository, so that they can pull this repository to, like, yeah, to their home directory there. So if you were to clone the repository, you could just do with SSH. You do get clone. It's not going to work because we didn't set up a key yet. So that's what we're gonna do next. Sorry. You want to create a new SSH key for this user. So SSH key, you don't have to pass the other, or just leave the other configurations as default, and make sure it's this SSH directory, the default one, and just press enter to everything, and then cat .ssh idrsa public key. So you copy their public key and go to deploy keys, and then add a new one. So .NET. Yeah, make sure you don't give them the right. We just need to wait for now to synchronize the code bases to pull updates via Git. So if I do git clone again, it should work now. So .NET cd. Okay, so this is our root directory for the project. We're going to use that in the GitHub workflow action to actually connect to this server, and then basically pull changes from Git, and then pull changes from the container registry. So we want to actually add these right now, since we're working on these. We could just go to secrets. We want to add these for the next step. So for SSH, we're going to use an SSH action runner, and we want to pass these for credentials to it. So SSH host. SSH host is the IP for that server. And SSH username. I'll just call it user. Remember to set it that way. And so the user is .NET. Make sure you pass whatever your user is here, and then SSH password. That's the SSH password. For the port, it's 22. It's the default. I didn't set any port, so I don't need these anymore. Shouldn't worry about them. Next, we just want to, we want to make sure that it runs like locally first. So Actually, we'll just skip that step. For now, we know that our container is running. I mean, our virtual machine is running. If we go to the network tab, we actually have this RDNS host that Linode provides for us, which basically like runs whatever service is running on port 80. For now, there is nothing that's running. So if you do, it's HTTP, of course. We couldn't install SSL on this. It's like, yeah, right. So I mean, I'm diverting a level here. So once we have some service running on port 80, then it should be serviced in here. So since we're going to be running on port 80, we want to copy the environment variable, like duplicate that in the env file. So cp.sample.env, cp it as an copy it to the environment.env file, and then just edit it. Make sure you don't do this like it's only done like once. You don't want to override whatever changes you've made in case you've done so already. So I'll go back to my local one that I have. Just get rid of everything. Of course, it's going to be production, and this is going to be our host. And since we're running on port 80, because for this I didn't specify the port 500. I wanted to run on that domain as it is. So since we're doing that, we need to remember to actually change the password. I mean the port to be 80 from port 5000. Yeah, so actually it's hard-coded, so we need to take care of that as well. So since it's hard-coded to port 5000, we actually need to make it work with the env file. So I'm going to add another variable here. HTTP port is equal to 5000, sorry, and make it here. I mean, these are already supposed to be in the .env sample file, so just adding them there for GitHub, of course. That repository is going to be public for everybody to duplicate. So instead of just a hard-coded string, I'm going to make it pull from this instead. So it's it should be port, and it should run smoothly. So just come back to that env file and set this to be port 80. We want the Docker to actually run our service in port 80. So make sure that port there's no service like running on that port. To check, you could just do ln sudo just to see what's running. Like right now we have Ssh running on that port. That's for some DNS. Yeah, make sure that port 80 is not occupied. So you don't want to have Nginx running or Apache. If they were running there, then make sure to disable them. You could also use the proxy forwarding, like reverse proxy with Nginx, and leave it running on localhost 5000, and then forward all requests to that. Once you so you can have Nginx pass the requests to your Docker containers. So I suppose everything is good so far. We can just move to the next step, which is running the deploy job, like configuring that deploy job, which runs on Ubuntu latest. But this one actually needs that one to be successful build. So we don't want to run this unless this build is successful. We have everything pushed up to our containers, and it's going to use steps. It's going to use Ssh Action by So it uses this action template, and we remember the ones we've configured in secrets. Yeah, we're passing them right now. So for SSH, passed SSH host, and for this one, SSH username. I think it's just user. And for port, it's 22. It's default. So if I come back to the repository here, you see that I actually have these SSH these SSH credentials saved as secrets. So host username, just double checking, password, and the script is going to be multi-line one. So it starts with that pipe. I don't need that stuff anymore. So yeah, just consider that whatever you're running here, it's going to be running on the container. The virtual machine that we have here as the user that we specified via the SSH user. So it's going to be this one. So first, when it logs in, it goes to the home directory, which is this one. We want it to change directory to .NET CD. So yeah, we'll copy that step here, and once it does that, we want to pull changes from the remote repository. So get pull origin master. So you see that it's already up to date. So we want to pull changes from GitHub, and after doing that, we want to let's see. I actually want to get rid of these caches of the images that get rid of these containers that we have, like the images that we have built. Just to remove them, we can do docker remove image. Let me just show you here the images that we have. Docker is so these are the images that if we want to get rid of. So it would be something else for you. Make sure you specify the name of your hub username in the repository itself. So we want to forcibly remove them. So it's that one, and we do the same for one for .NET Core and one for the application database. And the tag is latest, so we pass that as well. So we're specifying which image is going to be removed. And because Docker actually throws an error when, throws an exit code when that's not 0, when this image doesn't exist, like you deleted it before, that would mean that the script would fail, because whenever some step runs, gives an error, then the whole process, the whole workflow fails. So we want to make sure it's always successful. So we just do or fall back to true. So the exit code will always be 0. So that's the image that now that we have the images deleted, we can just add some comments. Then remove. Next, we want to pull images from remote. So remote in this case would be the container registry. We're using Docker. Sorry, yeah, we're using Docker Hub. So since we're using docker-compose, you can just do that, do docker-compose. Build has this pull step, which you can just pull from the remotes. So it's going to do that step for all of the containers that we have. We don't have to duplicate that command for every single image that we have. So docker-compose, that's the process of docker-compose. So doing that, and it's also, we could just add this to be safe. The cache is already deleted, but it doesn't hurt to have it there. And once that is done, the last step is basically just to refresh the containers that we have running. We have containers running here, we want to restart them. So we can say docker-compose -d enforce recreate. So force recreate is going to make sure that they stop and then start again. So if you made any changes to that env file or anything, if you don't, unless you run this one, it wouldn't be synchronized to the container that are already running. So just to make sure we double check everything. So yeah, we have everything there. Make sure it's important that you do the steps that I've just done and clone the repository, add this Ssh Key and everything. And yeah, if you're using a different directory, make sure you have it here. So that's an important step. So now if I do docker get status, it's going to show me that changes that I have. Once that is pushed, then it's going to trigger 2 jobs, one for build and another for deploy. So you see, yeah, but this will take a little while. I'll just pause it for a little here. Cut through the video. Well, actually, that didn't take long to throw an exit, to throw an error for us. Ports contains an invalid type. It should be a number or an object IC. It's actually giving us this error because we touched this file instead of creating it. I mean, our requirements changed, like our circumstances changed. Now we actually need to have this HTTP port there. So it couldn't map an empty string to a port. I mean, that's the validation error that we're getting right now. So what we can do is just -f. If it's not there, then we duplicate it. So cp. So if the file doesn't exist, then we duplicate it from there. And it's going to, I mean, it's no big deal. It's not even used, but the docker-compose wants to have this there just for the build process. So so we've got the latest job running here. It should work this time. Oh, fingers crossed. So yeah, we're back. So that definitely took some time to build and then to deploy. So the deploy step takes more time because it executes on that SSH agent and it runs those. I mean, the GitHub one machine would be a lot faster. So if I refresh here, you can see that these are actually refreshed recently. So yeah, 4 minutes ago, and we have these up and running. If I go to Docker, I mean the virtual machine right now, I should see Docker running, the containers running already. And if I exit and do that ls off, you can see that ports should be occupied. So port 80, I have something running in port 80, which is our .NET application. So if I open this one, it should work. Yeah, so this is now our homepage. And if I go to /members, it lists me everything. So yeah, everything is there. I'll just recap. Yeah, once you push to the master branch, because that's what the action is tied to, then you should trigger this build and deploy process. And it takes an overall of like 5 minutes, is it? Yeah, so as the last step, what you want to do is, like for Ubuntu, you want to have a reboot survival script. So your app would be running when in the event that your server crashes and restarts. I mean, like with Linode, they always perform security updates and they have your machines rebooted. So we want to use it like we could just do that right now. We'll switch back to that app user. Sorry, it's .NET Core. And it's .NET. So if you go to the root of your project, what we want to do is we want to create a cron tab that hooks to the reboot script. So that's where we will we'll basically do docker-compose up -d. So we want to find the real path of docker-compose. No, which docker-compose. So that's going to be our command. Just save a reference of that here. Up. But we want to pass the file location. So real path docker-compose -f. And then you do up -d. So yeah, why I'm doing these real paths for everything is because in crontab, yeah, it attaches like it runs with a separate user, and it doesn't necessarily run on this directory or have these binaries in the path. So you have to make sure you pass the right, I mean, absolute real path for those files in binaries. So you want to do crontab -e, and that's going to be, make sure you do it as the user that's running these containers. So it's .NET right now. So .NET crontab -e, which is going to edit. It asks us for an editor because that editor variable isn't set up yet. So it does that. We're just going to delete this. Make sure you use nano if it's a lot easier to work with, unless you're okay with Vim as well. So you do a reboot. So we want a reboot script. It's going to be, yeah, what we just did. And exit. Now we have those cron jobs. If I reboot the server, it should survive that reboot, and our app which should be running, like, should be running again. So basically, yeah, that's it. Yeah, to review again, whenever you push to your repository, you should expect to see an action running here, and when you click that, you should see those steps that you define. Yeah, it's going to deploy everything to your live server. And if you want to add SSL, then you could use containers. You could use certbot container for SSL and install like SSL certificates, even with its encrypts, which are basically free certificate authority, which you can use. And I guess that's it. If you have any questions, let me know down below. Thanks for watching.